Welcome back. In this video, we're going to look at how to find the maximum value or the minimum value of a quadratic function. Remember, in the previous videos, we saw that the graph of a quadratic function was a parabola. So we're going to use that fact and that knowledge of what these parabolas look like. We're going to use that to figure out how to find the maximum value or the minimum value of a quadratic function. So let's look at an example. Question 4 on the worksheet for lesson 20. So in this question, we're going to be talking about the quadratic function f of x equals negative 2/3 x squared minus 8x minus 26. So question 4 part A says, does this function have a minimum or a maximum value? So how can we figure that out? Well, we see it's a quadratic function, and we know we can write down the coefficients a, b, and c, and we know that a gives us some information. Because a is negative, it's negative 2/3, that tells us that the parabola is going to open downward. So it looks like this. The vertex is at the top. So that means the vertex gives us the highest value. So that means that this particular function will have a maximum. If it opened upward, so if a were positive, we would have a minimum. But we know we've got a maximum. So now in part B. Part B says, where does this maximum value occur? So where does it occur means what x-coordinate will give us the maximum value. It's asking for the first coordinate of the vertex. So we know the vertex lies on the axis of symmetry, and we know the equation of the axis of symmetry is x equals negative b over 2a. So that means that the x-coordinate of the vertex is also negative b over 2a. So let's find that. Plug in negative 8 for b, negative 2/3 for a. We get positive 8 over negative 4/3. Simplify a little. We get 8 times negative 3/4. Cancel a little. And we get negative 6. So that's the x-coordinate of the vertex, or the x-coordinate of the maximum value, the highest point. All right, part C says, what is the function's minimum or maximum value? So what's the difference between part C and part B? So part B asked, where does that maximum value occur? We found that that was the x-coordinate of the vertex. So part C is the actual maximum value of the function, f of x. So in part C, we're looking for the second coordinate, or the y-coordinate of the vertex. So that is what we're looking for, the y-coordinate of the vertex. So the only way we have to get that is by taking the x-coordinate and just plugging that in to f. So we're going to find f of negative 6. Plugging it in, we get negative 2/3 times negative 6 squared, minus 8 times negative 6, plus 26. I get negative 24 plus 48 minus 26, and I get negative 2. So that's the y-coordinate, or the output, at the vertex. All right, let's do some word problems. So number 5 says, a ball is thrown vertically upward. After t seconds, its height h in feet is given by the function h of t equals 64t minus 16t squared. And the question is, after how long will it reach its maximum height? So how long, is that their input or the output? So how long refers to time, right? And time in this problem is represented by t. And t is the input because the function is h of t. And the output is going to be height. So because it's asking after how long will it reach its maximum height, we know we're looking for the vertex. But in this case, we're looking for the first coordinate of the vertex because we're looking for t, or input. So let's rewrite the function in standard form. So I'm putting the t squared term first. So it's negative 16t squared plus 64t. Now writing it in this way makes it easy to see what A, B, and C are. So A is negative 16. So we know it's opening downward. So we know that the vertex is the highest point. So that makes sense because we're looking for the point where it, a point in time where it reaches its maximum height. So now we're looking for the vertex. So the vertex is always going to be negative b over 2a. That's the first coordinate of the vertex. And then the second coordinate is going to be the function h evaluated at negative b over 2a. So the first coordinate, the input, is always negative b over 2a, and then the output is the function evaluated at that number. So since we're looking for time, we're looking for the first coordinate. If the problem had asked us for the highest point, or what was the maximum height, we would be plugging that time into the function to get that maximum height. But all we need in this particular problem is t. So let's find it. We're going to plug in 64 for b and negative 16 for a. So we get negative 64 over 2 times negative 16, which turns out to be positive 2. So then to answer the question, we have to use units. So we can say it will reach its maximum height after t seconds. Okay, so we were looking for the input or the first coordinate of the vertex in this problem. Let's look at another one. So in this one, it says a medical equipment industry manufactures x-ray machines. The unit cost C, which is the cost in dollars to make each x-ray machine, depends on the number of machines made. If X machines are made, then the unit cost is given by the function C of x equals 0.6 x squared minus 108x plus 21,252. And the question says, what is the minimum cost? So we know we've got a quadratic, so we know the graph is going to be a parabola, and it looks like A is positive, so it's going to open upward. That makes sense, and that's good, because then we will have a minimum cost, not a maximum. Now, are we looking for X, the number of X-ray machines that are made, or are we looking for cost? So in this question, it's asking us for the minimum cost. So that means we're going to find C of X. Okay, we're going to look for the output at the vertex. So we do need to find the vertex, but we're going to find, in the end, the second coordinate, or the y coordinate. Okay, so the minimum value of the function is the cost, and that's the y coordinate of the vertex. So A is equal to 0.6 B is equal to negative 108, and C is equal to 21,252. So now we can start plugging in. So the vertex, again, is going to be negative b over 2a, comma, C of negative b over 2a. So we do have to first find the input. We have to find the x-coordinate of the vertex. That's going to be the number of machines that you have to make to minimize your cost. So let's find it. So x is going to be negative 108 over 2 times 0.6. And so simplifying that, we get a positive 108 over 1.2, which is 90. So that means you have to make 90 machines to minimize the unit cost. So let's figure out what that minimum unit cost is. We have to plug 90 in. So we're finding the unit cost of making 90 machines. So we're plugging 90 in to the function. C of 90 is 0.6 times 90 squared minus 108 times 90 plus 21,252. So this is 0.6 times 8,100 minus 9,720 plus 21,252. So that's 4,860 plus 11,532, and I add those together, and I get 16,392. Now, this is unit cost, so I'm going to answer the question. The minimum unit cost is $16,392. So we had to find the output of the vertex, the second coordinate of the vertex. So in the previous problem, the ball being thrown up, we had to find the first coordinate of the vertex because we were looking for the input. In this problem, we needed the second coordinate, which was the output. And the only way to do it was to first find the first coordinate, or the x-coordinate, and then plug that into the function. Okay, so you have a few more word problems to do to get some practice.